Okay, hello student. So in this lesson, we are going to start with our new chapter, which is probability. Actually, you have learned this concept in Sec 2, okay, but you only touch about the simple part of the probability. And in this topic, there are altogether three different subtopics. So the first one, we are going to learn about the tree diagram or even the possibility diagram, because that one is very important for you to learn and solve the questions. um, I mean, in the last two subtopics. Then for number two, you will learn about the additions of probability, and the last one, which is 3.3, is about the multiplications of probability. Okay, so just do a quick revision with you. So previously in Sec 2, so what have you learned is that you actually learn, like for example, you are given a Fey dice. Okay, Fey dice meaning that like a 6 surface, okay, and each surface is labeled with number 2, 1, 2, 3, 4, 5, 6, meaning that you have 6 numbers on the dice. And then after that, let's say my event A is like an experiment that you want to make. Okay, let's say when you roll the dice, okay, so the event A is asking for the probability of getting number 1. Okay, so you know that this Fey dice got 6 faces, right? Meaning that the chance, okay, the chance for you to get a number 1, okay, when you roll the Fey dice will be 1 over 6. So why is it 1 over 6? Because out of all the possible outcome, there are 6 altogether. Okay, you need to know all these words, possible outcome, or what we call the sample space. Meaning that when you roll a dice, what are the possible outcomes that you are going to get? Let's say, because there are six surfaces, right? Meaning that the possible outcomes will be 1, 2, 3, 4, 5, 6. If I want to represent in the set, then this is my sample size. 1, 2, 3, 4, 5, and 6. So this will be my sample space, okay? My possible outcomes. Then after that, because just now your A is asking for the chance to get a digit 1, okay, or you can get a digit 2 or whatever, but you know that this 1 is only one of the surface, okay, on the dice, meaning that out of the 6 surfaces, there is only one surface with number 1, meaning that every time when you roll the Fey dice, right, the chance for you to get 1 is actually 1 out of 6. So the 6 is actually the total possible outcome, meaning that there are 6 possible outcomes that you are going to get. But out of these 6, there is only one number 1, one digit 1, which your event A wants you to get. So that's why this will be our probability. And in this topic, usually all the answers, not usually, in this topic, all the answer for the probability, we will write it in the form of fractions. Okay, but actually when you learn higher, okay, or in university, when you take the courses about probability, usually the answers will need you to state in the decimal form. Okay, decimal form. Okay, so this is what we have learned previously. And then now let's look at 3.1, the probability of a simple combined event. So just now, the one that I explained to you, the example of a Fey dice, meaning that you only use one dice, right? That is called a simple event. Simple event means you only involve one process at one time, meaning that just now the experiment is roll a dice, meaning that you only roll a dice at one time. Or even you can just say like you throw the, what we call, the coin. Okay, usually the coin got 2 surfaces, right? Either is the head or the tail. So the head or the tail is actually the possible outcome. Okay, and if you are throwing a coin, the possibility or the probability for you to get the head is actually 1 over 2. Why? Because there are only 2 surfaces and you have 2 possible outcomes, and head is only one of the surface. So that's why it's 1 out of 2, meaning that every time you you throw the coin, the possibility for you to get a head is actually half of it, which is 0.5, half. Okay, so you in this one, why we have the word combine is because you are going to see, if let's say you are asked to throw 2 dice at the same time, what will be the possible outcomes? And That is why you need to learn two diagram later. The first one is called the possibility diagram, and the other one is the tree diagram. Okay, of course, these two diagrams, it will going to help you to see or to write out the possible outcomes in a more systematic way. But if let's say you are familiar with the questions already, right, actually you don't need these two at all. But sometimes the question might ask you to draw, okay, might ask you to draw, especially in question A. Yeah? So there are something that you need to know. A random experiment, meaning that every time you pick one, like say you want to pick one ball from a bag, and the bag consists of maybe 5 green balls and 4 red balls. So the possibility for you to pick a red ball at a random experiment, meaning that you randomly choose one. That is called a process that involving chance that generate a result called the outcome. And then the probability of an outcome means like how many percent, okay, or how much is the chance for you to get the possible outcome, the outcome that you want. Okay, and then sample space is considered as all the possible outcome. That is what I said just now. For the Fey dice, there are 6 surfaces, right? Meaning that the sample space for a Fey dice will be 1, 2, 3, 4, 5, 6. There are only 6 possible outcomes. But if let's say you have 2 Fey coin, you roll at the same time, meaning that you roll the 2 Fey coin at the same time, then the possible outcome will be will have more lah, okay, because you involve 2. And then the event is like the things that you want from the experiment, okay, like the outcomes that you want from the experiment. Okay, now the basic properties of the probability, I think you already know this one. Remember, our probability of something to happen is between 0 to 1, meaning that the highest possibility will be 1. 1 meaning that is 100% you will get the result, meaning that there is no chance. It's like you will definitely get the result that you want. Okay, now if it is 0, if the probability is equal to 0, means it won't happen at all, meaning that it definitely you will not get the result. Okay, so that's mean most of the time you will get the answer in the fraction form, and the values is in between 0 to 1. Okay, so you see, the probability of a sample space is always equal to 1, meaning that for all the outcomes to happen is actually equal to 1, and the certain event is also equal to 1 if let's say it really happened and it involves all the sample space. That is called probability of 1. 1 meaning that it definitely will happen. And then impossible event meaning that it will not happen, so the probability will be equal to 0. Okay, and one more is the complement. E complement meaning that the result that you want is actually out of E. Let's say the E is the event of choosing a red ball from the bag. Then the E complement will be the result or the probability for you to get a green ball. So the red ball and green ball, they are not related to each other. So that is called a complement. That means somehow you need to remember what you have learned in the first topic, set. Okay. Now, let's look at the first diagram, possibility diagram. And remember for this one, you have 2 types. Personally, I prefer the second type, which is this one, the possibility diagram. This is also the possibility diagram, but in the way that you need to list out the element. Okay, let's say here, a very simple example. So we will now look at the possibility diagram. An unbiased coin is tossed and the letter is selected from a random from the word amend. So this is the word that you are going to choose a word from there randomly, meaning that you just simply take one. Maybe all these letters are written on the paper and then you put it in a box and then you just choose from there. So you need to select a letter. So all these letters are different, right? So altogether there are 1, 2, 3, 4, 5. There are 5 letters. And then for the unbiased coin meaning that the coin is fair, meaning that the chance for you to get a head and a tail is the same, meaning that there is no bias at all. So this one you have 2 possible outcomes. Okay, 2 outcomes. Now, find the probability of getting a head on the toss coin and a letter M from the word. As you can see, this probability is not just mentioned about one particular outcome, like you want to get a head. Of course, if you want to get a head, the probability will be 1/2, right? But now, you see, yeah, you want to get a head on the coin, and you have the word and, meaning that these two outcomes, you want it to happen at the same time. So in that case, right, if you are not very familiar, of course, you need to use a possibility diagram to help you. So what can you do is, you draw a vertical axis and a horizontal axis like this. Okay, then after that, on the horizontal axis, that let's say you want to choose a letter from the word a man. So you have 5 letters, right? So you write A, M, E, and D. So you have 5 letters here. Then after that, for the coin here, you have 2 outcome, which is T and H. Okay, for the coin. So you see, you got 2 parts. The first one is from the coin, and the second one is from the letters. Okay, and usually, if let's say this letter is still okay, but let's say the T and H, right? The T and H, usually you need to write at the side of your diagram saying that your T is actually represent what? Let's say your T is represent cal. Then you have to write like this so that people know that what is the meaning of the letters that you use. You have to state at the side. Okay, then after that, from here, they just put a cross if there is an outcome for this combination. Let's say the first outcome, you put a cross here, meaning that you will get an A from the letter A from the words, and the other one is the head from the coin, meaning that this outcome is possible, then you put a cross. Sometimes if it is not possible at all, meaning that you have to put a dash, meaning that if you have no possible if this combination is not possible to happen, right, then you put a dash. If it will happen, then you put a cross. Later on, you will see some example whereby uh the two combination cannot happen at the same time. Okay, now the other one is, which is this one, alternatively preferred using this one. Why I say I prefer this one? Because you see, the letters, they write it out A, M, E, and D, and the other one is the coin, which is T and H. They put it in the table form, then after that, they write out the outcomes. Let's say the first one is the choosing, they get a tail from the coin and also the letter A from the words a man. Then the second one is TM, TE, TN, TD. So when you look at all these possible combination, right, then you straight away know that, oh, this T is stand for tail and the A is actually the letter A, so you know the outcome of the combination. But if you use the previous one, whereby you just put a cross, right, later on when you want to calculate the probability of certain event, then it will very difficult for you to refer back, because you look at the cross, you don't know what does it mean. You still have to look back what is the vertical component and the horizontal component. Then only you know the combination. So that's why I prefer the second type. Okay, and these two are considered as probability diagram. Both of them can be used. It's up to you. Okay, which one you want. So I hope you know what is this. So let's look at the example 1. So the first one is the two fair 6-sided dice. This is the example that I used just now. So 6-sided dice, meaning that you have a dice with 6 surface, like a cube shape. You have 1, 2, 3, and then 4, 5, 6 the other side. And these two, they are thrown at the same time. Thrown at the same time means like two you throw together. It's like just like gambling lah. Okay, and find the probability that the sum of the two numbers shown is 10. Of course, some students, they can just easily know that what is the combinations of the two numbers to get 10 from the dice. Okay, but since we are learning the possibility diagram and the tree diagram, I'm going to use the possibility diagram to show you first. Okay, let's say you want to draw a possibility diagram for the 6-sided dice, meaning that the first thing is you need to draw a table. Okay, of course, you need to use a ruler. You cannot be like me here. Okay. Now, what you can do is, oh, sorry. Okay. Here, what can you write is, this is your first dice, and this is your second dice. Okay, you can just write like that. The first stand for the first dice, and the second one is stand for the second dice. And then after that, you know that each dice, there are 6 surfaces, right? So you have to write out the number. Let's say this is number 1, this is number 2, this is number 3, this is number 4, and this is number 5. And last one, we need another one, which is 6. So same thing to the horizontal one. The second dice also has 6 surfaces. So you just write 1, 2, 3, 4, 5, and 6. So the table is not enough. So you better draw it properly. Don't be like me, okay? Because I don't have ruler on the screen. Okay, then after that, you just complete the table. Okay, complete the table. Let me finish it. It will take some time. Okay, then after that, what you need to do is, let's say from the first dice, you get 1, second dice, you get 1. So you will get the outcomes of 1, 1. Okay, usually numbers, when you are asked to list out the possible outcome, which consists of number, we will put 1, 1, and then we'll put a comma in between and put in a bracket. This one is just like one outcome. Okay, one outcome. Then the second one is, from the second one, you start with 2. So 2, 1. Then after that, 3, 3, 1. Remember, if this is your first dice, then you have to write this number at the front part. Okay, you cannot just mix around. Like for the first one, you write 1, 1. Then the second one, you anyhow write 1, 2. Then the third one, you write a 3, 1. Cannot be. Okay, you have to follow exactly the sequence. If let's say you want to make the first dice as the first result in your possible outcomes, then you have to start with the 1 and the 2 for the first dice. So this is 2, 1, and then 3, 1. Then after that, 4, 1, 5, 1, and then 6, 1. Why I said you must follow the sequence, because 1, 5, and 5, 1, even though they have the same number, but as long as the sequence are different, they are considered as 2 different outcomes already. Okay? Now, the next one will be, we start from the first one also. We have 1, 2. We have 2, 2. We have 3, 2. We have 4, 2. 5, 2. And then 6, 2. Then after that, you have 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, and 6, 3. Then after that, you have 1, 4, 2, 4, 3, 4, 4, 4, and then 5, 4, then 6, 4. Then you have 1, 5, 2, 5, and then 3, 5. Then after that, 4, 5, then 5, 5, then 6, 5. And lastly, you have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. Okay? And every time when you draw, you better go and check back what is the whether all the possible outcomes you have written are correct or not. Okay? And now, they want a probability whereby the sum of the two numbers is 10. Then you have to check one by one, meaning that when you plus the two numbers from the two dices, you must get 10. So the probability of the first one, you have to write like this. So for A, let's say you want to write the probability. So the sum is 10. You have to write the P stand for probability, and then in bracket, what is the event or what kinds of result you want. So the sum is 10. And then you know that your probability consists of how many results out of the total. So there are total how many outcomes? So you see you have 6 columns and 6 rows. So altogether there are 36 outcomes. Okay, there are 36 outcomes. And then if you want the sum of 10, so what are the possible outcomes? So you can list out. Okay, you can list out here. I have not enough space, so I better like here. So you can put in the bracket in the set form, listing the elements. So the first one, let's check the first row. Any one of them equal to 10? No, right? Then the second row, 4 plus 2, 6, 5 plus 2, 7, 6 plus 2, 8. No. Then go to the next row. 4, 3, 7, 5, 3 is 8, 6, 3 is 9. No, still no. Then go to the next one is 6, 4. Okay, so the first one will be 6, 4, the first outcome. Then after that, the next one you will get is 5, 5. 5, 5, yeah. 5, 5 is one of the result because it's equal to 10, 5 plus 5. Then after 6, 5, no. And then 4, 6, yes. So you see, there are 3 possible outcomes for this event, meaning that for the first one, the numerator here, you have to put 3 because out of the 36 outcomes, there are 3 of them which fulfill this situation. And then you can simplify from there. So 3 times 1, and then 3 times 1, 3, 3 times 2, 6. So this 1 over 12 will be your probability of getting the sum of number, which is equal to 10. Okay? And always remember when the question asks you about the sum of the two number, or can at least one die show 3. So all these events, you have to list out the outcome first. You cannot straight away refer to the table and write your probability straight away. You need to list out your outcome. I repeat, you need to list out your outcome. Okay. Then for the next questions, okay, for the next questions, not enough space. Maybe I do it up here. Okay, maybe up here. So for B, you want at least one die show 3. At least one die show 3, meaning that it can have one die showing 3 or two die showing 3. So this one is quite easy. If you look at the table, just look at the row and the column with 3, which is this one and also this one. Of course, there is one overlapping. You just write as one time. You don't need to write 2 times. Okay. So the first one, you just write, okay, 3, 1. Then after that, 3, 2. Then after that, 3, 3. Then after that, 3, 4. Then after that, 3, 5. Sorry. Then after that, 3, 6. 3, 6 is the last one, right? Then go to the other one is 1, 3. Then after that, 2, 3. And because 3, 3 you already wrote, okay, so no need to write the 3, 3 again. Then after that, 4, 3, 4, 3. Then after that, 5, 3. And the last one is 6, 3. So list out the possible outcomes in the bracket. Then after that, you have to write down the probability. So the probability is at least one die shows 3. You must write this one in this form. You cannot just put a P and then equal. No, no way. You have to involve the event in the bracket. So there are altogether 36 outcomes. So still the same 36 outcome. And out of these 36 outcomes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 outcomes. Okay. With at least one die show 3. So because this one cannot simplify, so this will be your final answer. Okay, this will be your final answer. So this is for the first questions. Then the second questions, a bag contains 2 gold coins and also 1 silver coin. So 2 coins are drawn one after another without replacement. At random from the bag, find the probability of getting 1 gold coin and 1 silver coin. For this one, you will notice that there are 2 gold coins and also 1 silver coin. 2 coins are drawn at random one after another without replacement. This is very important. Meaning then once you pick up 1 gold coin, you cannot put back. You have to continue with the second coin. Okay, you have to continue with the second coin. So this is very important. The word without replacement, these 2 words is very important in this topic. Because without that 2 words, they will give a very different outcomes. Okay, so let me show you. Again, you have to draw a possibility diagram. Of course, this time the possibility diagram will be simpler because you only have two types. So let's say you want to choose 2 coin, right? 2 coin you want to choose. So let's say this is the first possible coin that you are going to choose, and this will be the second possible coin that you are going to choose. And then of course, every time when you want to pick one possible coin, you will have 3 coins to choose. You have 3 possible coins for you to choose. Okay, so your table should be like this. So during the first time, you will get 2 gold coin. You will have 2 gold coins. So let's put at G1. And then the second gold coin, you put G2. Then the next one will be 1 silver coin. Just put S because it's only 1. And why I put G1, G2? Because there are 2 coins and you have to assume that the 2 coins are different. You cannot just make them 1. Okay, it's different because of course 1 gold coin, 1 silver coin, the possibility is 1 to 1. But let's say you have 2 gold coin, the chance for you to pick a gold coin will be higher because you have 2 of them. Okay, then after that, the other side, you will also have G1 G2, and then S. Okay, now, in the previous page, I told you that sometimes the combinations cannot happen. Let's say this one. In your first coin, if you pick G1 as your first coin, and then you never put back, right? Because without replacement, this word, without replacement. If they say without replacement, you don't put back, meaning that inside the bag, there is only G2 and silver coin left, G2 and also S coin left. Meaning that for the first one here, it's not possible at all. So either you put a dash or you put a cross, okay? Or you put a cross because it wouldn't happen at all. Because after you choose G1, meaning that there is no more G1 in the bag, okay? There are two other coins, which is G2 and S, meaning that the possibility for you to pick the second one will be G2 or S only the two possible coins. So if you choose the G2, then I will have the outcome as G1, G2, okay? G1, G2. So this will be the first one. Then the second one, I will also have G1 and then S. I will have this outcome also. Okay, of course, when you draw the table, you must show it properly. So the G1 means the first gold coin. And then the G2 stand for the second gold coin. And you have to write this legend means like what does the letters that you use represent. And the S represent the silver coin. Okay, next, when I choose G2 in the first place, meaning that I still can get G1, right? So you write G2, G1. But you can't get G2 anymore. So here you put a dash. And the third one, if you pick G2, of course, there is a possibility for you to guess or to get that silver also, which means that this one is possible. And the last one, if you pick a silver coin in the first place, there is a possibility for you to get G1 because it's still there. And also you have a possibility to get G2 also, but this is not possible because you don't have two silver coin because you never put back. So these are the possible outcomes. So the probability of getting one gold coin and one silver coin. One gold coin and one silver coin. So what is the possibility outcome? So the first one will be SG1, SG1. And then what else? You have SG2, SG2. G1 and G2 are two different coins, right? So they are considered as two different outcomes. Okay, you cannot just say, oh, because they are all gold, it should be one only. No, you have to make them two. Because we are finding in details how much possibility that you will get the result. So each of the coin you have to count it individually or separately. You cannot combine them. Then after that, we have also what? A G1S. Either you get the gold coin first and then followed by the S, or the second one is the G2 coin followed by S. So you see, when you list out, you will see clearly that there are actually four possible outcomes if you want to get one gold coin and one silver coin. Okay, then after that, when I ask for the probability, meaning that you have to write out probability of one gold and one silver. Okay, you don't need to write so long. You can write it in simpler way like this, but at least you need to step properly. And there are how many possible outcomes? So if you look at the table, there are 1, 2, 3, 4, 5, 6. There are altogether 6 possible outcomes. And from the event just now, you have 4 possible outcomes for the event. And then you can simplify. So 2, 2 is 4, 2, 3 is 6. So this is your final answer. Okay, this is your final answer. So this is what we call the possibility diagram. Okay, possibility diagram. Okay, next one, we go to the second part, which is the tree diagram. Okay, what is the difference between possibility diagram and tree diagram? You have to remember this. Please listen. Okay. For possibility diagram just now, if you look at the table that I have constructed, usually it's only one row and one column with the possible outcomes, right? Meaning that for possibility diagram, for the table type, you can only have you can only do it for the experiment whereby only involve 2 processes. If it is more than 3, you cannot use the table form. But this tree diagram, it is suitable to be constructed for an event with more two or more processes. Let's say you want to roll 3 coins at the same time. It is possible for you to do so. Okay, like the one example here, each time you roll a coin, you will have 2 possible outcomes. Like this one, when come to the second part, they do head, tail again, meaning that this is for the second coin. And this is for the first coin. Okay, first coin. And this is the example of a tree diagram. And this tree diagram only involve 2 processes, 1 and 2. Of course, you can make it more. Like let's say you throw the third coin also, right? You can just extend from here. You can just extend from here, extend from here, extend from here. Then your tree diagram will become very big. Okay, which is the next example. Let's look at the next example. You see, 3 unbiased coins are tossed. 3 unbiased coins are tossed. Find the probability of getting 3 head. Okay, of course, 3 head, you know that there is only one possible outcome, which is H, H, H. But in order to know there are how many possible outcomes, let's say you are not very familiar, you better draw a tree diagram to help you to see clearly. Because sometimes, even me also, I do the probability for a long time already. Sometimes I still make mistake because of the possible outcomes. Okay, so let's look at the first, let's draw the tree diagram first. So we have the first coin. Let's say this is your first coin. And you have 2 outcomes, right? Which is head and also tail. Okay, then the second coin, you also have this exactly the same outcome. I'm not sure whether enough space on. I think enough. So for the second coin, you also have 2 possible outcomes, which is H and T. H and T. Okay, then when come to the third one, we still do the same thing. From the first one, you get 2, and then 2, and then 2, and then 2. Then write down the letters HT, 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 HT. Okay, then after that, you can just write what are the possible outcomes or the possible combination that you will get. So for the first one, you see, you will get H, H, H. So write H, H, H. For letters, you don't need to put a comma. But for the previous one, the numbers here, you have to put a comma because if you never put a comma, then it seems like it's a number. Okay. Then the second outcome will be H, H, T. The second outcome is H, H, T. And the third one is H, T, H. H, T, H. Then after that, H, T, T. Then after that, T, H, H. Then after that, T, H, T. Then after that, T, T, H. And the last one is T, T, T. So from this one, you actually have how many? 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have 8 outcomes. Some people, some students, they will think that, oh, 3 times, 3 coins. So what are the possible outcomes? So some students just tell me that, oh, 3 times 3. So it's 9 outcomes. So wrong already lah. So it's better for you to draw a tree diagram to help you to see the outcomes clearly. So for the first one, because you want the probability of getting 3 heads. So the probability of getting 3 heads, you know that there is only one possibility, which is H, 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 right? This is the only possible outcome. And if you look at your tree diagram, there is only one, which is this. This is the only possible outcome. And out of how many just now? Out of 8, right? So that means the answer for this one will be 1/8. Okay, so this will be the answer. Then after that, if you want the 2 head and 1 tail, 2 head and 1 tail, they will have more possibility. 2 head and 1 tail. Let's check the first one. 2 head, 1 tail. This one no tail, so cannot accept. Then the second one, 2 head, 1 tail, yes. And then 2 head, yes. This one 1 head only, so cannot. Then the next one, you have THH, 2 head also, so can. This one 2 tail, cannot. This one 2 tail also cannot. This one all tail cannot. Meaning that the one that I tick is the possible outcome. So you can try to list out. So the first one is actually HHT and followed by HTH and followed by THH. Okay, so there are three possible possibility. So that's mean if I want to get a probability of 2 heads and 1 tail, there are 3 possible outcome, which means that the probability for you to get this result will be 3 out of the total possible outcome is 8, right? So this will be your answer, 3/8. Okay, so you list out first, okay, you see what is the possible outcomes, and then after that you look at the questions, like what the question asks for, like what kind of result they want. And from there, you see how many result or how many outcomes fulfill the conditions. And that will be your numerator. And your denominator is actually the total number of outcomes, which you have listed beside the tree diagram. Okay, this one. This will be the possible outcome, how many of them. Okay, so I hope you know how to use a tree diagram, okay, in order to construct. Okay, one more questions for the first part. The bag A contain 4 chips numbered 1, 3, 5, and 7 respectively. Bag B contain 3 chips numbered 2, 4, 6 respectively. So now you have 2 bags. Okay, bag A and also bag B. So bag A got 4 numbers and bag B got 3 numbers. I mean the chips lah. And a chips is drawn at random from each bag, meaning that you choose 1 chips from each of the bag. From bag A, you choose 1, and then from bag B, you choose 1. And they ask you to draw a tree diagram to show all the possible outcomes. Okay, so in this case, you have to list, you have to draw. Okay, so let's do it together. 1, 3, 5, 7, right? So let's say we start from bag A. So in bag A, there are 4 possible outcomes. 1, 2, 3, and 4. So what are the numbers in bag A? You have 1, 3, 5, and 7, which is the even number, right? Then after that, in bag B, because you have 3 numbers, so from each of the branch in bag A, you have to make 3 branches for bag B, because you want to see there are how many combinations. So from each of the branch in bag A, you have to extend for 3 branches. And these 3 branches is actually for bag B. So this will be your bag B number or the bag B chips. So the first one is 2, and the second one is 4 and 6. So this is even number. And followed by 3, you also need 3 branches. When you draw the branches, please, of course, try to use ruler. Okay, but this one I won't deduct your mark, don't worry. Okay, and then 2, 4, 6. Because basically this possibility diagram or the tree diagram is only to help you to see the outcome clearly. Okay, then after that, you will have the possible outcome. Okay, don't just draw the tree diagram. You must list out the possible outcomes at the side. So the first one is 1, 2. The second one is 1, 4. Then after that, 1, 6. It's actually quite easy to list lah. Okay, if you don't have the tree diagram also, I think you are able to do it. Hey, what happened to my pen? Sorry. Hey? What happened? Okay. Okay, the next one is 3, 2, 3, 4, and also 3, 6. Then after that, 5, 2, 5, 4, and also 5, 6. Then 7, 2, 7, 4, and 7, 6. So these are the possible outcomes. Of course, in the test, in the exam, you have to draw it nicely, okay? You cannot just draw like what I'm doing now. It's quite messy, yeah? Okay, let's look at the next one, the first one. You want to find the probability of the sum of 2 chips is equal to 7. Okay, so for A, the sum is 7, right? So let's see how many of them the sum is 7. The first one, 2, okay, this one, no, 6, 7. Yes, the first one is 1, 6. Okay, 1, 6 is accepted. What else? And then 3, 4, right? 3, 4 also accepted. Then after that, what else? 3, 6, no. 5 and 2 is 7. 5 and 2. 5 and 2. Wait, where is my pen? Excuse me. 5, 2. 5, 2. Too small, I cannot see. 5, 2, and then 5, 4, no, 5, 6, no, 7, 2, no, 7, 4. Okay, meaning that for the sum equal to 7, you have only 3 possible outcomes. So these are the numbers, the combinations of numbers that you will get the sum equal to 7. So meaning that what is the probability? The probability of sum is 7. So altogether, there are how many outcomes? So let's count together. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are altogether 12 possible outcomes. So for the denominator, just put 12. And then there are 3 outcomes there. So you just put 3. So the answer is equal to 1 over 4. That is the answer for the first one. Okay. Then after that, B also. Let's look at B. Sorry, this is B1. This is B1. Let's look at B2. You want the sum to be an odd number. Okay, let's see. I think this is quite a lot. The first one, 1, 2, yes, of course, because it's 3. And then 1, 4, yes, you will get 5. Then 1, 6, yes, you will get 7. Then after that, 3, 2, yes. Then after that, 3, 4, yes. Then after that, 3, 6, yes. Then next one, 5, 2, yes. 5, 2, 5, 2. And then what else? 5, 4, yes. Am I listing everything? Let's check. 5, 6, 5, 4 is 9, 5, 6, 11, 7, 2 is 9, 7, 4, 11, 7, 6, 13. Oh my goodness. So all of them actually. So I'm sorry. So for this one, you can actually write is equal to the sample space. Why? Because this event is actually referring to all of them. So you just write in bracket and then equal to sample space. So when the event that you are mentioning and the outcomes is exactly the same like all the possible outcomes, that means what is the probability? So the probability of the sum is odd will be equal to 1 because it will definitely happen. Meaning that if you want to get the two numbers where the sum is equal to an odd number, you will definitely get from this event because all of them, all the possible outcomes, when you plus the two numbers together, you get an odd number. Okay, I'm sorry I didn't notice that. Okay, now let's look at B3. Okay, just now you say all the sum is odd, right? Is equal to 1, right? That's mean if you want the sum to be even, do you think it's possible? No, right? If you look at all the possible outcomes, when you plus them all together, all the two numbers together, you actually get an odd number, meaning that for the probability of getting the sum, which is even, this one will be equal to 0. You will get a 0. Why? Because there is no outcome that fulfill this condition. Okay, there is no outcome fulfill these conditions. Okay, so this is the part about the tree diagram and also the possibility diagram. So remember, for possibility diagram, it only involves the things with the two processes. Then after that, for the tree diagram, it can have more than 2. That means you can choose for 3 coins or 3 dice. But 3 dice is quite a lot because each dice you have 6 numbers, right? So the tree diagram will be a lot. Okay, but the most important thing is you must know how to construct these two diagrams so that it will help you in the questions for the later part. Okay, for the later part. So I think that's all for this video. So please look at the next sections, okay, for the next video. Thank you very much. See you.